The most powerful storms on Earth go by different names: hurricanes, typhoons, or cyclones, depending on where they form. These names might sound different, but they all refer to the same incredible natural phenomenon: a gigantic swirling storm system that can stretch hundreds of miles across and unleash unimaginable power. Whether you call it a hurricane, a typhoon, or a cyclone, the science behind these storms is the same. They are all tropical cyclones, and their differences lie mainly in their location and the local naming conventions. Hurricanes specifically form over the warm waters of the Atlantic Ocean and the Eastern Pacific, where conditions are just right for these storms to develop and intensify. In the Northwest Pacific, these storms are known as typhoons, often threatening countries like Japan, China, and the Philippines with their immense force. Meanwhile, in the South Pacific and Indian Ocean regions, the same type of storm is called a cyclone, impacting places like India, Australia, and island nations across the region. These massive, rotating storms are fueled by warm, moist air rising from tropical oceans. As the air rises, it cools and condenses, releasing energy that powers the storm, making them nature's most destructive engines. They only form over warm waters near the equator, where sea surface temperatures are at least 26 degrees Celsius, or about 79 degrees Fahrenheit. The warmer the ocean, the more energy the storm can draw, allowing it to grow stronger and more dangerous. Unlike regular thunderstorms, hurricanes are vast and highly organized. At their center lies the eye, a calm, clear area surrounded by the eye wall, where the most intense winds and rain occur. The energy released by a single hurricane can equal that of hundreds of thousands of atomic bombs, making them truly awe-inspiring. Their powerful winds, torrential rains, and massive storm surges can devastate entire regions, flooding cities, destroying homes, and leaving lasting scars on the landscape. Throughout history, these storms have shaped coastlines and changed the lives of millions. No matter what they're called, these storms demand respect and careful preparation from everyone living in coastal communities. Early warnings, emergency plans, and community cooperation are essential to minimize their impact. In this video, we'll dive deeper into how these storms form, the science behind their destructive power, the damage they cause, and the steps we can take to protect ourselves and our communities from their wrath. Understanding the immense power of hurricanes, typhoons, and cyclones is the first step to staying safe and building resilience against nature's most formidable storms. Every hurricane or typhoon begins as a simple disturbance over the warm, restless waters of the tropics. At first, it's just a cluster of thunderstorms, barely noticeable on the vast ocean surface. But under the right conditions, this small disturbance can grow into one of nature's most powerful forces. The key ingredient is warm ocean water, at least 80 degree or 26.5 degree RC. This heat acts as the storm's fuel, causing the air just above the water to become warm and moist. As the sun beats down, water evaporates, and this moist air begins to rise, forming towering clouds that can stretch miles into the sky. As this warm, moist air rises higher into the atmosphere, it cools and condenses, releasing even more heat. This process lowers the air pressure at the surface, creating a sort of vacuum that draws in even more air from the surrounding area. The cycle repeats, and the storm starts to build. The Earth's rotation comes into play too. Thanks to the Coriolis effect, the incoming air doesn't just rush straight in, it spirals, giving the storm its signature spin. In the northern hemisphere, storms rotate counterclockwise. In the southern hemisphere, they spin clockwise. This rotation helps organize the storm, making it more powerful. If the winds high above the storm, known as upper-level winds, are calm, the system can continue to organize. The storm's structure tightens, and its winds grow stronger. But if these upper winds are too strong or chaotic, they can tear the storm apart before it has a chance to grow. This disruptive force is called wind shear. Too much wind shear, and the storm loses its shape, breaking apart before it can become dangerous. But if wind shear is low, the storm can keep building, layer by layer. When all the right ingredients come together, warm water, moist air, low wind shear, and the Coriolis effect, the system strengthens. It evolves from a tropical depression to a tropical storm, and finally, when sustained winds reach 74 miles per hour or 119 kilometers per hour, it earns the title of hurricane or typhoon. At this stage, the storm develops a calm, clear eye at its center, a striking contrast to the violent winds swirling around it. This eye can be dozens of miles wide, and the storm itself can stretch hundreds of miles across, traveling thousands of miles across the ocean, steered by global wind patterns. The storm's strength depends on the warm water it passes over. The more heat it absorbs, the more powerful it becomes. If it moves over cooler water or land, it begins to weaken, losing its energy source. From a humble disturbance to a ferocious cyclone, it's a perfect blend of ocean heat, atmospheric moisture, and the invisible forces of our planet. This delicate balance can unleash incredible power, shaping weather patterns and impacting millions of lives. That's how a monster is born. From the quiet warmth of the ocean to the roaring fury of a cyclone, a true marvel and menace of nature. Hurricanes and typhoons are deadly because of three main threats: wind, rain, and storm surge. Winds can exceed 155 mph, destroying buildings and turning debris into dangerous projectiles. Torrential rains cause widespread flooding, sometimes dumping over 20 inches in a single event. Flooding can persist long after the storm, damaging homes and infrastructure. The most lethal threat is storm surge, a massive dome of water pushed ashore by the storm's winds, sometimes over 20 feet high. Storm surge can wipe out entire communities in minutes. These forces often combine, overwhelming emergency services and making rescue nearly impossible. Power outages, blocked roads, and destroyed communication lines add to the chaos. Understanding these dangers is crucial for survival. Hurricanes are multifaceted disasters that demand respect and preparation. The deadliest tropical cyclone ever recorded in human history was the Great Bola Cyclone, which struck the coast of Bangladesh, then known as East Pakistan, in November 1970. This catastrophic event left an indelible mark on the region and the world, forever changing the way we understand and prepare for natural disasters. Although the cyclone was classified as only a Category 3 by today's standards, its impact was magnified by geography and population. It slammed into the low-lying, densely populated Ganges Delta, one of the most disaster-prone and vulnerable regions on Earth. The area's flat terrain and proximity to the sea made it especially susceptible to flooding and storm surges. A massive storm surge, reaching heights of up to 33 feet, swept over the coastal islands and mainland. Entire villages were erased in a matter of hours, as the powerful waves inundated homes, farmland, and everything in their path. Many residents had little time to escape, and the devastation was almost total in some areas. With few sturdy shelters available and almost no effective warning system in place, the population was caught off guard. Hundreds of thousands of people perished. Estimates range from 300,000 to 500,000 lives lost, making it one of the deadliest natural disasters ever. Families were torn apart, and entire communities vanished overnight. The aftermath was catastrophic. Crops were destroyed, livestock swept away, and clean water became scarce. In the days and weeks that followed, disease outbreaks spread rapidly among the survivors, compounding the tragedy and making recovery even more difficult. The scale of the disaster quickly overwhelmed local authorities, who struggled to provide even basic assistance. The international community responded with massive aid efforts, sending food, medicine, and rescue teams to help the millions affected by the cyclone. In the years that followed, the tragedy of the Bola cyclone spurred Bangladesh to take action. Thousands of cyclone shelters were constructed, and early warning systems were upgraded to better protect vulnerable communities. Education and preparedness programs became a national priority. The Bola cyclone remains a stark lesson in the dangers of vulnerability and the critical importance of disaster preparedness. It serves as a reminder of how quickly nature can change lives and how vital it is to be ready. The legacy of the Bola cyclone is measured not only in the immense loss it caused, but also in the countless lives that have since been saved by the changes it inspired. Today, Bangladesh stands as a testament to resilience and the power of learning from tragedy. Hurricane Katrina in 2005 proved that even developed nations are vulnerable. Katrina's storm surge overwhelmed New Orleans levees, flooding 80% of the city. Residents were trapped, many stranded on rooftops as water rose. The disaster exposed deep issues of poverty, inequality, and failing infrastructure. Over 1,800 people died, and thousands more lost their homes. Katrina's legacy is a wake-up call. Storm impact depends on where and how it strikes, not just its strength. Billions have since been spent to rebuild and improve emergency response. Katrina taught hard lessons about resilience and the importance of preparation. In 2013, Typhoon Haiyan, Yolanda, struck the Philippines with record-breaking winds of 195 mph. The storm's speed and intensity left little time to prepare. Tacloban and surrounding areas were devastated by a 20-foot storm surge and extreme winds. Over 6,300 people died, with thousands missing and millions left homeless. Relief efforts were hampered by destroyed infrastructure and communication lines. Haiyan highlighted the growing threat of stronger storms fueled by climate change. Developing nations like the Philippines are especially vulnerable. The disaster spurred global calls for better warning systems and resilient infrastructure. Haiyan is a tragic reminder of nature's escalating fury. Preparation is the key to surviving hurricanes and typhoons. Know your risk. If you're in an evacuation zone, leave early when told. Don't wait. Roads can quickly become impassable. Secure your home. Bring in loose objects, board up windows, and stock up on essentials. Food, water, medications, and batteries. During the storm, shelter in an interior room away from windows. Stay informed with a battery-powered radio, and never go outside during the eye's calm. After the storm, beware of downed power lines and floodwaters. Check on neighbors and document damage for insurance. Recovery is long, but preparation saves lives. Communities that plan ahead, endure, and rebuild. Your actions before the storm make all the difference. The eye of a hurricane is a calm, clear center surrounded by chaos. For those on the ground, the sudden peace can be dangerously deceptive. The eye forms as air sinks and dries out, creating a tranquil spot visible from space. Many mistake this lull for the end, only to be hit by the storm's fury from the opposite direction as the eye wall returns. Never leave shelter until officials say it's safe. The eye is a powerful reminder. In a hurricane, the greatest danger can follow the calmest moment. Stay vigilant until the storm has truly passed. We can't stop hurricanes, but science is our best defense. Satellites and Hurricane Hunter aircraft track storms days in advance, giving us crucial warning time. Dropsondes dropped from planes collect real-time data on wind, pressure, and humidity. This information feeds powerful computer models, improving forecasts and saving lives. Today's 3-day forecasts are as accurate as 1-day forecasts were decades ago. New technology, like ocean drones and high-res satellites, continues to advance our understanding. Scientists are working to predict rapid intensification, one of the biggest dangers. As climate change fuels stronger storms, this research is more vital than ever. Technology can't tame nature, but it gives us the knowledge to prepare and protect. Seeing the storm coming is our greatest shield.